Hello everyone, this is Bini from Emmanuel JJ College of Engineering, working as Assistant Professor in the Department of Computer Science and Engineering. Today, we are going to discuss the major objective of the object-oriented programming approach and understand why it is preferred over the traditional procedural programming approach. So first we can see about the object-oriented paradigm. Before object-oriented programming, most software was developed using the procedural programming approach. In procedural programming, the focus is mainly on functions or procedures that manipulate data. As software became larger and more complex, procedural programming faced several problems such as data being accessed by any function, difficulty in maintaining large programs, increased chances of accidental modification of data, poor code reusability, difficult in extending existing applications. To overcome these limitations, object-oriented programming was introduced. So, the main objective of OOPS are instead of focusing only on functions, OOP focuses on objects which combine both data and the operations performed on the data. So, the first objective is to eliminate many of the flaws found in procedural programming. That is why most modern programming languages like Java, C++, Python, and C# support object oriented programming. The next one is data protection in OOP. One of the most important feature of OOP is data protection. In procedural programming, data can flow freely throughout the program, allowing different functions to modify it. In OOP, data is treated as a critical resource. Data is kept inside an object and cannot be accessed directly by other parts of the program. Instead, data is accessed only through the object methods. This concept is called encapsulation. Because of encapsulation, data is protected from accidental changes, unauthorized access is prevented, program reliability increases. For example, in a bank account object, the account balance cannot be modified directly. It can only be changed through methods like deposit off and withdraw off. The next objective is objects and methods. Another important idea in OOP is dividing a real world problem into objects. An object represents a real world entity. Examples include student, employee, car, bank account, mobile phone, etc. Each object contains data, that is attributes. The data consists of student number, roll number, marks. Methods or functions display detail of, calculate grade of, or update marks of. The combination of data and methods form an object. This makes program more organized because every object manages its own data. Now we can move on to the next slide, that is basic concepts of object oriented programming. Object-oriented programming is based on the idea that objects are the most important part of a program. Instead of writing a program as a collection of functions, OOP organizes the program into objects. Each object contains its own data and the method that operate on that data. The main goal of OOP is to represent real-world entities inside a computer program. Almost everything around us can be considered as object such as a student, teacher, car, mobile phone, bank account, or even a book. For example, think about a college management system. Instead of creating one large program, we divide it into different objects like student, teacher, department, library, and course. Each object has its own information and responsibilities. The student object stores student details while the library object manages books. This makes the program well organized, easier to understand, and easier to maintain. OOP is used in many modern programming languages such as Java, C++, Python, C#, and Kotlin. Java is completely based on object-oriented programming, which is why understanding OOP is very important before learning Java programming. Now we can see what is an object. An object is any real world entity that has state and behavior. The state refers to the characteristics or properties of an object, while the behavior refers to the actions that the object can perform. Let us take a car as an example. The state of a car includes color, brand, model, speed, fuel level. The behavior of a car includes start, stop, accelerate, apply brake. Here the car itself is the object. It has its own properties and performs certain actions. Similarly, consider a student. The student state includes name, roll number, department, age. The student's behavior includes attend classes, write examinations, submit assignments, view result. These examples show that every object has both characteristics and actions. In Java, an object is an instance of a class. This means that an object is created from a class and occupies memory in the computer. Now we can see what is a class. A class is a collection of similar objects. It acts as a blueprint or template for creating objects. A class defines what properties and behaviors its object will have. However, the class itself is only a logical concept. It does not occupy memory until an object is created from it. Consider the example of fruits. Apple, orange, mango and papaya are all different objects. Since they have similar characteristics, they belong to a class called fruit. Similarly, Rahul, Priya, John and Meena are different students, but all of them belong to the student class. Now consider the objects apple, table and bed. This cannot belong to the same class because they are completely different types of objects. Apple is a fruit, table is furniture and bat is sports equipment. Since they are not similar, they cannot be grouped into one class. Now we can consider a real life example of class. Imagine a school. The school has many students. Every student has a different name, a different roll number, a different age. Although the values are different, all students share common characteristics such as name, age and roll number. They also perform similar actions like attending classes and writing exam. Therefore, student is the class, each individual student is an object. Now, we can move on to the next slide. Now we can see about inheritance. So what is inheritance? Inheritance is the process by which one class acquires the properties and behaviors of another class. The class from which properties are inherited is called the parent class, and the class that inherits them is called the child or subclass. Inheritance helps us reuse existing code instead of writing the same code repeatedly. Let us consider a real life example, family. Suppose a father has certain characteristics such as black hair, brown eyes, height. The child naturally inherits many of these characteristics from the father. Similarly, in Java, the child class inherits variables and methods from the parent class. Why do we need inheritance? Inheritance helps us code reusability, easy maintenance, reduces duplicate code and also it creates a parent-child relationship. Now we can discuss about polymorphism. The word polymorphism comes from two Greek words. Poly means many, morph means forms. So polymorphism means one interface, many forms. The same method or action can behave differently depending on the situation. Let us consider the word run. It means changes depending on the context. For example, a person runs in a race. A car runs on petrol. A computer program runs on a computer. So these all statement has different meanings. So why do we use polymorphism? Polymorphism helps improves flexibility and it makes programs easier to extend and it reduces complexity and also it supports code reusability. Now we can discuss about abstraction. Abstraction means showing only the essential features and hiding the internal implementation details. The user only needs to know what the object does, not how it does it. Let us consider a real world example. When you drive a car, you only use steering, brake, accelerator, gear. You don't need to know how fuel is injected, how the transmission works. The internal mechanism is hidden from the driver. This is called abstraction. Now we can see the uses of abstraction. Why do we use abstraction? Because it helps hides unnecessary details and also it reduces program complexity, it improves security and also it makes software easier to use. In Java, abstraction is achieved using abstract classes, abstract methods and interfaces. Now we can discuss about encapsulation. Encapsulation means wrapping data or variables and methods together into a single unit, which is called a class. It also means protecting data from direct access. Instead of allowing other classes to change the data directly, access is provided through methods. Let us consider a real world example. Think about a medicine capsule. Inside the capsule, there are different medicines mixed together. You only see the capsule from outside. Similarly, in Java, variables and methods are packed together inside a class. So, why do we use encapsulation in Java programming? It protects data and also it prevents unauthorized access and also it improves security and it makes programs easier to maintain and also it supports data hiding. So today we have discussed some of the basics in the Java programming. I will be continuing in the next session.